Hello, and welcome to the next part of the algorithm section. Yes, I'm still excited despite the next topic, which is probably my least favorite. You see, in the past, when I learned about sorting, it involved a lot of math, a lot of different algorithms, and I just never really enjoyed it because I didn't understand why we needed to know sorting. I mean, you just have a sort function usually in a programming language, and that's it, right? I just never understood the point of it. And you're probably thinking the same thing. All right, Andre, there's nothing to learn here. I'm going to skip over these sections. Great lesson. See you later, right? Well, not really. Let me explain. In an interview, sorting is really important. You hear questions like, take an array of numbers and sort them, or the interviewer wants you to do something to some input, and they tell you that this input is sorted. And you're wondering, why did they just tell us that? Why does it matter if it's sorted or not? And why do companies care so much about sorting if I can just use the built-in sort method in my own language? Well, here's the thing. Sorting is not a big deal when it comes to small input data. You'd be right. You can just do something like this. We'd have an array of letters, and this array simply has A, D, say Z, let's add a few more E, R, and finally B. And if somebody asks us to sort this, well, we can just use something like a sort method that comes with most languages. And if I run this, look at that. Nice and easy, just sorted everything. I'm a genius, right? Why would companies ever ask such a simple question of us? You see, the problem is when inputs get larger and larger. Kind of like when we talked about Big O. We don't care about small inputs. That's easy to do, especially with our modern fast computers. It starts costing companies a lot of money when we have to perform operations on larger and larger data sets. That's when things become a little bit crazy and expensive. For example, Google has a ton of websites that are indexed. What if they need to sort those websites in a way? Perhaps sorting a news article based on the time that it was released. And because we're talking about Google here, we're not talking about 10 articles. We're talking about thousands, millions more articles sorted based on date. What about Amazon? Amazon is all about sorting. They sort their products based on category, based on price, based on rating, and they have millions of products. What about Apple? Well, Apple has the Apple Store, and they list all their apps in some form of a sorted order. Podcasts in a sorted order. What about Microsoft? Well, Microsoft, they need to sort all their logs of, let's say, their data centers around the world, so that if an incident happens, they know where it's coming from. And then Netflix? Well, they need to sort their shows, their movies, their TV shows somehow, right? And they can't usually just use a built-in sort method that comes with the language. And they usually need custom sorted methods based on the data so that they can lower their costs and lower the operations that their computers need to do. Most places sort their data or pre-process it. And all these companies, including small ones, usually sort data to make sure that it's meaningful. If it's random data that is not sorted, it's really, really hard to access. So most of the time, we sort data or pre-process it. Now, the examples that I just talked about, they are a little bit silly, but it does prove my point. For these companies, if they do something wrong or they do it in an inefficient way, it means losing a lot of money. That's why they ask these questions in an interview. They want to make sure you understand how important the topic is and that you can make the right decision as their employee. What sorting algorithm should you use based on the problem? So that's the goal of this section. I'm going to show you how to implement sorting on your own if you want. But most importantly, we're going to talk about the different sorting algorithms available to you and how you can make the right decisions for your company. And obviously, to ace that coding interview. Now, the reason that most sorting algorithm lessons get really boring is that there's so many sorting algorithms. If we search sorting algorithms on Wikipedia, you get a pretty large list. And implementing these sorts one by one yourself takes a lot of time. But most likely, you will never implement your own sorting algorithm in your life, except for maybe a simple one in an interview. Because most of these, especially the advanced ones that are really fast, are done by academics that spend years figuring out what the best, most optimal way of sorting is. And interviewers don't expect you to be able to implement every single sorting algorithm. My goal in this section is to teach you the high level, what you need to know to become a better engineer and also ace the coding interview. I'll show you how to implement some of the important sorting algorithms, but more importantly, we're going to talk about the trade-offs between them so that you're able to talk about them intelligently during an interview. For the next few videos, we're going to talk about these sorting algorithms and also a couple of bonus ones towards the end. But the key thing to remember is that as more and more data is handled by our computers, which is a big trend in computing, sorting and searching are two of the biggest computer science problems in the software world. Searching we're going to get into in the next section, but sorting is something we'll hopefully master at the end of these videos. So let's go learn how to make good decisions when it comes to sorting.